Welcome to Irwin Data Modeler Tool Training. These courses are meant to get you up to speed quickly with Irwin Data Modeler. In the two Advanced Modeling Techniques courses, we'll be working with data models and on data models with Irwin DM's most powerful features. In this course, we will delve into the capabilities of Irwin Data Modeler that go beyond just building a correct and complete model. One of the most powerful features that Irwin Data Modeler offers is the bulk editor. Those capabilities include finding metadata within the model and modifying metadata within the model. It is one of those vastly underutilized capabilities of Irwin Data Modeler. It enables you to select and change just about anything in the model. Let's pull up the bulk editor from our View menu, Windows, Bulk Editor pane, also Control-B. I'm going to undock it since it's impossible to use docked. The bulk editor, this gadget enables you to select and change just about anything in the Irwin DM model. The bulk editor even allows you to make use of external tools like Microsoft Excel as an extension of your data modeling tool. I'd like to position the bulk editor where we can watch what's going on in the model below, because as we make changes through the bulk editor, those changes will immediately take place in the diagram that we're looking at. In our basic modeling techniques course, we use the report designer to build a report to show us attributes whose parent domain was the default domain. And that's terrific if you need a report like that. Reports allow you to share information with other people, with other members of the modeling group. But what about when you're in heads-down modeling mode and you're building a model rapidly, you need to make changes rapidly? No items to show. What do we have in our toolbar? Some things that we're familiar with. We can move back and forth among siblings. We have an undo and a redo button. There's a file open, a bunch of other buttons. The one that we're really interested in here is the wizard button. It looks like a worksheet with a magic wand and some sparkly little things going on above it. Launch the wizard. The overview tab just tells you what this is all about. Let's select object types. And here we're going to select the types of objects you want to display in the bulk editor for editing. One of our choices is column. We have a lot of choices here. Now, the next link on the left, property types. Property types of what? Property types of column. Everything here is available for the column object type. So for property types, let us select domain parent. And data type, where am I going to find data type here? Logical data type. And especially if you can't find the item that you're looking for where you think it should be in the list, don't forget to check the prefix logical or the prefix physical. The next link on the left, object instances. Select the model objects to display, etc. So we only have one object instance, that is column. Oh, no, we've got a lot of object instances. All of these are columns in our model. Well, I do want to include all of them, but I could be selective. I'll just check the box by column. We have a display order link. I'm going to display in order by domain parent and then logical data type. So let me grab domain parent and use the upward pointing arrow to move domain parent above. There are some user settings here at the very bottom on the left. I'll let you read through those. We're not going to change anything here. And our action buttons at the bottom right, edit, cancel, or help. Well, edit means edit the model, not to edit the wizard settings. We can just click in our links on the left to do that. Push the edit button, and here we go. Just as with the report template builder, we can move the columns into different positions. We can sort by column. Right now, if I want to sort by the name column, if I click on that header, now they are in order alphabetically. Right-click on a cell, and you'll see a list of options that the bulk editor allows. Copy this cell as text. What about the second column? And the third column. Harden logical data type in all selected rows. What does that mean? Override logical data type in all selected rows. So selected rows, of course, they're referring to Control-click or Shift-click. But one of the things that we wanted to look at was which columns still, at this point in our modeling process, have their domain parent as default. There's a filter box at the top right. Many Irwin guided editors have these. Please don't forget them. So I want to see just the columns whose domain parent is default. And the name of the default column begins with a left or a less than caret. And that's all we need. Boom. Now bulk editor has been filtered. We're only looking at columns that still, at this point in our process, are associated with the default domain. And notice that the domain is considered the parent of the column, not the other way around. The filter settings limit the display, but they also limit the changes we can make. Maybe that's exactly what we want. Another interesting button in the toolbar is second from the right end. Edit the selected object. Well, let me select Advance and push that Edit button, and it launches the attribute editor. And look where I'm positioned. In the Entity Book, the column Advance, just as out here in the Bulk Editor. And I can edit anything that I want to here. Let me check Customer. Nope, Customer is not in our list. Why? Well, because the filter is being applied from the Bulk Editor. Customers here, we can get to the entity, but there are no columns in Customer that are using the default domain. We might want to be changing the domain parent of all of these for some reason to the same domain parent other than default, but I think not in our case. Notice the logical data type for Advance, which is an author. Logical data type is money, but the domain parent is still default. Let's take a look at that one in the Properties Editor again. Logical domain, money. Aha! Look at the logical data type down here at the right side of the General tab. Remember our little icon meetings? This has been overridden. The logical data type had been inherited from default, which would have been just char 16. So what would be a reasonable parent domain for money as a data type? Not default. Let me change it. In fact, let me go out of the editor momentarily, back into the Bulk Editor, and for Advance, let me drop down the domain parent list and select number. Oh, it's disappeared. Why? Because it's no longer associated with the default domain. It no longer meets my filter condition. So are we sure that our change stuck? Well, let's undo it and see if we get our troublesome Advance back again. We sure do. For Advance, let me open the Properties Editor. I can see I'm in the Entity Book, the column Advance. I'm going to change the parent domain from default to number. And the money logical data type still overrides. Inheritance is overridden. So we haven't done anything to reestablish inheritance yet. And close the Properties Editor. In fact, before we close it, notice that Advance no longer appears in our list in the Bulk Editor. Now we could, in fact, select, let's take book type. There's another instance of book type. One's apparently a foreign key. Change both of these at one time. Let's change them to string. And of course they disappear from our list because they no longer meet our filter condition. I want to use the undo button. That undoes our entries there for book type. They're back to the default. I'm going to select these first several columns that have the first word in their name as book. And one of the interesting buttons in our toolbar is Save Selected Rows to CSV file. It's a little diskette picture. We can save it out to a CSV file. What can you do with CSV files? We can load them up in Excel. I'm going to relaunch the wizard. I don't have to start all over again. I can relaunch the wizard to change some of the wizard settings. And this is really important what we're going to do here. Let's select Object Types. And this time, previously we just selected Column. And then underneath Column, we selected Domain Parent. Let's select Column this time and Domain. So now we have column and domain both selected. Let's take a look at the property types that are available. Well, logical data type and domain parent. Why? Just keep that in mind. Go back to object types again, and we'll unselect domain, and this time select table. Now let's look at the property types that are available to us. And I'm going to look for logical data type. Not here. Physical data type. Not here. Parent domain. Not here. In fact, to make that a little bigger screen here, I can see all of the property types. Well, this is fewer property types than I used to have for column. Now I've got column and table selected. What is going on? Well, the bulk editor is rather intelligent. And what it has done when we selected multiple object types at this level, then the next level, our property types list, is only going to include properties that are in common, properties that both columns and tables have. Both columns and tables have comments. Both columns and tables can be logical only. They both have names. They can both be associated with themes. So the only property types that we'll see listed here are the ones that are shared, are held in common by all of the object types that we've selected. And that's going to save you just knowing that. The bulk editor is terrific when you are making changes in bulk. You have many, many changes to make. Look at what we've demonstrated. You could change the domain of every column in the model. Can't imagine why you'd want to do such a thing. But that would be an exceedingly bad thing to do. But that's the power of the bulk editor. Are there limitations with the bulk editor? Well, I think you could consider this object type interaction not so much a limitation. If you utilize it, it's very, very powerful. Both tables and columns, as we saw, have names, so that property still shows up. But columns have a physical data type and tables don't. So there's no physical data type property for us. Many times there is an option to show the owner of an object. So the owner of a column is a table. So be aware of the power of the bulk editor. The fact that you can relaunch the wizard from the middle of some process. The filtering capability, which again is a common capability in many, many guided editors in IrwinDM. The fact that we have our own undo and redo buttons in the bulk editor, but their actions are not limited to what goes on in the bulk editor. Let me undo, and you'll notice in the action log, I've got a couple of new entries. Undo again. Yeah, a couple of new entries. Redo, redo. So the action log is being affected by the bulk editor. I don't consider that a limitation at all. I consider that a great power. I want to demonstrate how to make some changes using an external tool. In this case, it'll be Excel. We want to change the word customer everywhere it appears in our model. Change it to client. I'm going to change it in entity names and attribute names, table names, column names, and in definitions as well. Launch the bulk editor, Control B, and launch the wizard. Object types. Well, we said we wanted columns and tables. Property types. Well, comment would be the equivalent of a definition on the physical side. So we better take that. Definition and name, meaning logical name, as well as physical name. Object instances. We need to have access to all these tables. How about we just do the filtering? All the tables and as well all the columns. Display order and user settings, nothing that we need there. So let's push the edit button at the bottom right and bring all this into the bulk editor. This is everything in the model. Well, all the tables and all the columns anyway. Definitions and comments. Show you the whole thing. Our first step is going to be to export this by saving it to a CSV file. And I'm going to make a CSV file, customer-client. I told it I did not want to save only the selected rows. I want to save everything. Now let's go find that customer client and launch it. It brings up our friend Excel. Some information in the column headers, all object IDs and such, and in the leftmost column, column A. The only place we want to search is columns B through G from the second row to the bottom. In almost all cases, you do not want to edit the IDs as they're the key to positioning the data back into the model. Control H in Excel will launch our Find and Replace screen. I'm going to replace the word customer in all uppercase with client in all uppercase. So I'm going to ask it to match case. I've got that option set. Let's replace all. Made 3 replacements, that's all. And I see one right here on row 11. Used to be customer table, now it's called client table. Well, now let's search for an initial capital letter and the rest in lowercase. Once again, match case, replace all. 39 replacements this time. And finally, all lowercase, as we might find in definitions and comments. And it made a lot of replacements there, 44. Okay, I'll close my Find and Replace. Okay, now I need to save my changes to that CSV file. Now, back to Irwin Data Modeler. In the toolbar, the button just left of the little diskette button will be to import model updates from CSV file. Notice the customer entity is peeking just over the top of the bulk editor. So let's push the import button. Once again, select customer-client CSV and open. Uh-oh. And the reason it didn't open for us is that we still have the file open in Excel. So let me close Excel. Back to Irwin Data Modeler. And try again. Import model updates from CSV file. Notice on the diagram beneath us, that entity that used to be named customer now shows client. And all of its attribute names have been changed to client. The casing is proper, uppercase, lowercase. So all those places, the bulk editor has made it possible for us to change customer to client. So that's a simple change, but imagine trying to make it without bulk editor. So you need to know what you're doing with the bulk editor, but it is absolutely an incredible capability. Well, that's just a brief introduction to the bulk editor. We want you to be comfortable and well prepared to explore further on your own. In this course, our objective for referential integrity is to understand how Irwin Data Modeler handles the desired outcomes of referential integrity decisions in an Irwin data model. In the next course, Advanced Modeling Techniques 2, you will see techniques that you can use in Irwin Data Modeler to implement referential integrity. But again, this is all about modeling the desired RI outcomes. This module will include our first foray into editing the properties of the model itself. Now we're going to take a look at modeling the desired referential integrity outcomes. Let's change the display option for the diagram. Notice we're in our familiar publications model. In the book subject area, see up here in the title bar, on the physical diagram, the display of referential integrity options is a diagram property, so we're going to open up the diagram properties editor. And on the relationship tab, in this box full of options at the bottom, relationship physical display options, check the third box, display physical referential integrity, and close at the bottom right. And now our referential integrity settings are shown for each relationship here in the physical side of our model. I'd like to draw your attention to the relationship between publisher and book. This is where we'll be working in this demo. This is an optional relationship. In other words, each publisher is associated with 0, 1, or more books, and each book is associated with 0 or 1 publishers. So we can have a book with no publisher. That's what the 0 or 1 means. The publisher is optional. Hence the foreign key, publisher identification. We have to allow that to be null. Well, all this D:NA and such, these are the referential integrity options that are being shown as a result of the change we made to the diagram properties. D stands for delete. U stands for update. I stands for insert, the other kind of action that can have referential integrity implications. Insert, update, or delete, the 3 actions. The option here at the parent end, the publisher end, for deletions is take no action. So if somebody is trying to delete a publisher, even if it has books associated with it, don't take any action, don't do anything. That worries me. We also have a no action rule for parent update. Again, even if there are books associated with the publisher and somebody's going to change the publisher identification, the primary key of the parent, take no action. We have the same delete and update rules for the child. The rules down here, D:NA, this is interpreted as child delete. So on child delete, no action. On child update, no action. So if we try to change the foreign key in the child book to a value that doesn't match any existing publisher primary key, publisher identification, that's no action. Why do we not see any rule for insert? Well, we'll see why in a minute. It has to do with the availability of other options besides no action. The referential integrity defaults in a model are model-wide. They are properties of the model. We need to take our first look at model properties, all the way down at the bottom of the model menu. Let me quickly walk through these tabs just so you can be familiar with what's here. These are model level properties. The name of the model, the author's name. We see just recorded here the fact that this is a logical, physical, combined, or classic model. It's targeting SQL Server 2016. The notation is IE, Information Engineering, also called crow's feet. There's a tab labeled Defaults. This has to do with default attribute null options and default non-identifying relationship null options. Default logical and physical data types, default themes. I'm going to skip over referential integrity defaults, RI defaults, for a moment. History options. This is where we determine what objects we want to save history for and what kind of historical events do we want to record. There's a definition tab. This is a definition for the model. We will use this model for user-defined properties. They're handy, they're handy. Remember, these are for recording structured metadata. History, see this model was created, it was not reverse engineered. And notes and extended notes, we've talked about those in the past. Now let's go to the RI Defaults tab. Notice we have 3 rows for child tables, 3 rows for parent tables. For each kind of table, we have rules for insert, update, and delete, so-called actions. We're concerned here about the actions that can be taken on a table that might upset referential integrity. We have 4 columns where we can set options. One column is for each relationship type, identifying or solid line relationships, non-identifying dash line relationships that allow null foreign keys or that do not allow null foreign keys. In other words, nulls allowed, these are optional relationships. No nulls into foreign keys, these would be mandatory relationships. And the rightmost column for supertype subtype relationships, sometimes called generalization hierarchies, for each combination of table and action and relationship type. We have a drop-down list of choices. So here in the column for nulls allowed non-identifying relationships, one of my choices is restrict. One of my choices is, set null. Right now it's set to no action. Set null, that's interesting. Nulls are allowed on these relationship types. Let's look at mandatory relationships, non-identifying no nulls, child delete. Now there's restrict, but I don't see any set null. No, I can't have a set null. That's not a valid choice for this column. This column does not allow null foreign keys. So for this model, we want to restrict if there's a danger to referential integrity. My rule for parent delete, instead of no action, will be to restrict. In the relationship between publisher and book, if someone tries to delete a row from a publisher table, even if that publisher ID, that particular publisher, has a book or 2 or many associated with it, we're going to restrict it. If there is no book associated with it, well, then in implementation time and in the database, we don't have to do anything. There's not a referential integrity issue there. So for non-identifying nulls allowed relationships, we've changed to restrict for parent delete. For child delete, I'm going to change that to restrict also. Well, that's interesting. Notice what's happening out here in our diagram. When I changed the child delete rule to restrict, I got my child delete restrict. But when I set restrict as the option for parent delete in this kind of relationship, it didn't change in the diagram. It still says parent delete NA. Well, let's see if the toolbar here is any help. The second button will reset all referential integrity default settings to their original values as installed with Irwin. We want the first button, the leftmost button, rebind referential integrity settings on all relationships. I've made the changes here, but if I want to be sure that they take place in a model, I push the rebind button. Would you like to rebind? Yes. And now, notice in the diagram, at the publisher end of our relationship, the rule is parent delete restrict. Let's close the Model Properties Editor, and there we've made some changes to the model level defaults for referential integrity settings. Again, those defaults are like all defaults. You want them to represent the situation that you expect to happen most frequently. So we have some defaults that will apply to all relationships in a model. But of course, they're just defaults. They're not universals. For some relationships, we're going to want different options. Let's take a look at how we can make that happen for this relationship between publisher and book. The referential integrity option for a particular relationship is a property of the relationship. So let me open the Relationship Properties Editor. And we're going to look at the RI Actions tab. Here we see our child delete rule restrict, parent delete rule restrict, just as we changed and rebound the model level default values. I want to make a couple of changes to the RI rules here at the relationship level. I don't want to make these changes model-wide. I just want to make them for this one relationship. The first rule we're going to change applies to parent insert. So if someone tries to insert a new row for publisher, parent insert rule, let's change that to no action. And right away it shows up in the diagram. We don't have any rebinding to do here. That's all done automatically for us because it only is applying to a single relationship. The rebinding that we did earlier rebinds to all of the appropriate relationship types in the model. For child insert rule, I'm going to change that from none to restrict. And here I have at the child end of the relationship line, I:R, child insert restrict. This means if someone tries to add a row to the book table and the foreign key value that we're entering does not match a valid primary key in the parent table, we're going to restrict that. We're not going to allow that. So we're just changing the referential integrity options for this one relationship. And we'll close out of that. You may find, as I do, that having the relationship options showing all the time makes your diagram very, very busy. But it's handy to be able to turn them off and on as you need to, so you can double check the settings, make sure they represent what you want, and then maybe you'll turn them off again when you're done working on a particular diagram. So that's how to set the model level referential integrity default values, and also how to override the defaults for referential integrity at the relationship level. So this has been a quick introduction to model properties, specifically referential integrity option defaults. Irwin Data Modeler's metadata bridges allow us to bridge our data model to a myriad other sources and uses of model metadata. Irwin DM includes a large set of metadata bridges. These allow you to import metadata from and export it to a huge range of other sources. We'll get a glimpse at just a few of these. We'll find them under the File menu, Import, and Export. Let's take a look at the imports. Import from external format. The overview page gives you information about what it is you're about to do. This wizard allows you to convert data from another application into a format recognizable by Irwin DM. The next tab is Source. We're going to see a long list of sources. Drop down the type list, and we'll go up to the top. When you have a chance, go through this list in your own copy of Irwin Data Modeler. Visio database diagram. How do you turn a diagram into a real, by golly, model in Irwin DM? Just a tremendous wealth of import opportunities here. As with our other demos, we want to prepare you to explore an aspect of Irwin Data Modeler. We're going to further that preparation by showing you how to do just one simple example. We're going to pick as our import source COBOL copybook database files. Well, not really a database, is it? It's just a bunch of physical tables out there. Location asks us for the file. This is our source. It's just a COBOL copybook. Okay, that's the file we're going to use as our source. Validation. We have some choices here. We're going to select basic consistency check, but we can do no consistency check if we're already familiar with this copybook. Some parameters here. These all depend upon what you're doing and the nature of the source. Next tab, Destination. Up at the top, the location of our destination. And let me make a unique name here so we don't get trouble from Windows. UTL HOSP 2-2.xml. The checkbox for Open Model, if that is checked, then when the import's finished, we'll see an Irwin Data Modeler model. We're ready to finish. And we'll see progress on the importing. Do get a warning, could not understand database file 1.0.0, setting target database to something else, ODBC generic. And let's close the messages. This file has been loaded, a default name for saving the set, etc. Maximize this. Take a look at the Model Explorer at Entities. We have a number of entities, but they sure don't look much like entities, do they? They look like tables, which is what they are. So if we want to see something like an entity relationship diagram, we're going to have to pick some automatic layout. I think I'll just step through the various layouts and fit model just to see if one of the particular layouts looks like it offers some promise. This is interesting. When we pick circular layout, we get two big circles of things. Try hierarchical. Looks like maybe supertype, subtypes going on up here. Orthogonal layout. Yeah, that looks pretty interesting too. Again, with the layout tools, you can set out part of the diagram as one style and another part of the diagram as another style. Let's zoom in. It's going to take some documentation to be able to translate this into words we understand. But that's pretty wonderful to be able to take a COBOL copybook and in a matter of a minute or two to have an Irwin DM data model. Well, now you should be prepared to delve further into metadata bridges. We've just touched the surface, but you've seen the kind of things that are possible with metadata bridges in Irwin Data Modeler. Design layers is a particular Irwin DM approach to data modeling. It enables straightforward management of complex workflow in a modeling project. It also facilitates designs that require coordination of more than one model. The classic Irwin Data Modeler modeling using combined logical physical models is sufficient for many, but not all projects. An architecture is just a standardized plan for building something. Situations where the Irwin Data Modeler classic architecture of combined logical physical models is a better fit include where the logical and physical design is done by the same group of people, or where there's a single implementation schema. These argue in favor of the simplicity of the classic logical physical combined models. Here is just one example of a design layer architecture. Notice the differences between this and the previous slide. Here we have a set of coordinated models being developed by different groups of people for different purposes. We have the logical development and then the generic physical design. From there it splits into the implementation of two different schemas by two different groups of people. So, situations where design layer architecture is a better fit for your data models would include those where logical and physical design are done by different groups of people, where design and implementation are done by different groups of people, where there's more than one implementation schema. You'll notice a lot of arrows here labeled sync. This is short for sync with model source, synchronize. It utilizes the technology of Irwin Data Modeler's Complete Compare. We'll cover that in the next Advanced Modeling Techniques 2. We're going to begin constructing our design layer architecture from a logical model. As you can see in the little toggle in the toolbar, this model is logical only. It does not have a physical side. Of course, when we start a brand new model, we have that opportunity to create a logical only model. But if we have an existing model, that is Irwin Data Modeler Classic model, or one of those combined logical physicals, we can split that model from the Actions menu, Design Layers, Split Model. And that will take the combined model and create a separate logical only model and a separate physical only model. These are the commands that we have available to us when we're working in the design layer architecture, along with split model. We can derive new model. We're going to be doing that here just in a moment. Sync with model source, link model source. This allows you to connect all the tables and columns in a model with the entities and attributes in another model, even though you're not synchronizing them at that same time. And add model source. So any one model may be derived or synchronized with any number of model sources. Imagine we have a physical model with, for example, 5 tables, a little tiny model. Each one of those tables could have its source model, a different logical only model, or a different physical model, or some combination. So this really does allow us to pull together various schemas, as we saw in the slideshow, or break apart into various schemas. Very, very powerful stuff here. The sync with model source is a bit beyond us right now. In our second advanced modeling techniques course, we will be covering complete compare, and sync with model source is based on complete compare. We're going to work with constructing the architecture here. We're starting again with a logical only model. Let's see what we have. This is the whole model. Pop open a Model Explorer, and this is all we see. Notice we have a many-to-many relationship at the top right corner. Also, notice with the other four entities, we have a generalization hierarchy, sometimes called a supertype-subtype relationship. The supertype here is the employee table, and we have three subtypes. Part-time, of course these are part-time employees, full-time employees, and seasonal employees. For each of the subtypes, there's different information that we need to capture. This is an extremely powerful logical modeling technique, but it's not relational. It can't be implemented in a relational database. The same thing with a many-to-many relationship. In at least one data modeling methodology, the many-to-many relationship is referred to sometimes as a non-specific relationship, and that's its challenge. Again, it's a powerful way to think of things if that's the way the organization thinks of them, but it cannot be implemented in a relational database directly. Nonetheless, both the many-to-many relationship and the supertype-subtype especially allow us to capture a tremendous amount of information in the logical model about how we need this set of entities, ultimately a set of tables, how we need them to behave, what we want the business operation and opportunities of these data elements to be. And we're going to refresh your memory of some behaviors that without design layer architecture, they could cause us some problems. Okay, well, here's our issue. For some reason, we need to implement the physical side that doesn't yet exist for this system on two different relational database management systems, Oracle 11g and SQL Server 2008. The implementations are going to be somewhat different for lots of reasons, but both implementations need to reference the same logical design specification. It is, after all, a single business organization with a single set of requirements. That's our logical model, right? It's the design specification. So both implementations need to reference the same logical design specification. The two implementations are going to be not just built in different RDBMSs, but the implementations will be designed by different groups of people. Many components of the two implementations in our example here are going to be very similar, but it's this logical model that's going to remain the repository, if you will, of the original design requirements. So we begin our design by having built this logical-only model. And now, from the Actions menu, select Design Layers, Derive New Model. Our target model is going to be a new model, and it's going to be physical. Create using template. Well, we only have one model template right now. The target database is going to be ODBC/generic. We're going to have a design layer that allows us to build our generic physical design model. Then from that generic physical model, we will derive an implementation model for Oracle, and we'll derive another separate implementation model, physical-only model, for SQL Server. On the left, click the Type Selection link, and we'll jump to the next tab. Now we're looking at the new model. So we get a warning. This model has no model level diagrams, nothing to show. But that's what we're going to do here. At the top, filter level, since we're going to be building a physical-only model, we can't have any choices for logical level information. What does this mean? Logical level, physical level, database level. Well, notice the text at the top, Derive Model Type Selection. Please select the types of objects to be derived. What's the difference between physical and database? Well, physical, if you scroll around through this tree, the option tree, you'll see things like themes, page setups, naming standards, images. These are all things that you might find in an Oracle Data Modeler physical model. If we were to check database level, we don't have any of that. We have just things that you could find in a database. Default values, relationships, tables, validation rules. Well, this model, our generic physical design layer, is going to be physical level. As you saw when we jump between those two checkboxes, it's the choices in our option tree that change. Notice also we have the option set drop-down list. The advanced default option set gives you everything in a physical-only Irwin DM data model. We're going to select standard default option set. And you notice a lot of the checkboxes have disappeared. So this is much cleaner. Notice also there are toolbar buttons to the right of our option set. Open a stored options set. Save changes. Save current selections as a new option set, or delete the option set. We have lots of options. I mean, this just goes on. There's hundreds of choices in here. So if it's something that we want to use again on another project or another model in the same project, we might indeed want to save our option set so that we can reuse it. On the left, object selection. And now we have two lists. These lists are checked off the way they are because of the choices we've made up to this point. We're not going to make any changes here, but you can see how we could have a finer level of control. We only have one subject area in the model, so it's checked. We could turn off particular types of indexes. Now all this list on the left, this tree on the left, says choose objects using sets. So we mean by that sets of indexes. For example, primary key, foreign key, that's a set of indexes. Triggers, schema owner. The list on the right is very specific to the existing and to the new model that we're deriving. It's based on all the changes we made on these previous tabs in the wizard, plus the changes that we made on the left. Relationships, domains, supertype, subtype symbols, tables, and so forth. Let me demonstrate how these two lists work, these two trees. Expand indexes and unclick foreign key. We notice we get a check in the tables tree. Let's expand that. Employee project, full-time, part-time, seasonal, these have all been changed. Yeah, we're not going to have any of our foreign key indexes because we turned off the entire set of indexes on the left for foreign keys. Let me turn them back on, and we're back to where we started. Very, very powerful, but all this stuff works hierarchically all the way down through the list. Let's take a look at the final link on the left, naming standards. Notice with the naming standards link selected, we have access to some interesting stuff here on the right. An option to remove vowels. Very quick way, quick and dirty, as we say, to generate physical names. Whether we want to allow special DBMS characters, or we can enter the name of template path to apply naming standards. We're going to be seeing them very shortly in this course. Okay, we're ready to derive our physical only model. Push the derive button at the bottom in the middle. And here we are. Control A to select all, and now push the motorcycle button. Notice what's happened. Our many-to-many relationship is replaced by two one-to-many relationships which connect to our join table. This model, by the way, is physical only. You can check that up at the top. Logical physical says physical, and there's no changes. If you look at the Model Explorer, you see we have tables branch, but no entities branch. The other thing that's been modified here is that our supertype-subtype relationship has been resolved into this series of identity relationships. These are 1 to 0 or 1 relationships. If we were to do this, if we were to just accomplish the resolution of the many-to-many relationship and the resolution of our generalization hierarchy in a combined logical physical model, we'd see something very similar to this on the logical model. And the problem with that is we've lost all the specifications about how we really need this system to work. You know, if you show a logical model without the generalization hierarchy and maybe without the many-to-many relationship or the non-specific relationship, there may be constraints that nobody knows how to create. Nobody knows what the constraints are supposed to do, needed to do. So it's very handy to retain that logical model, and we do still have it. There it is. So that's a very nice advantage. This model is set to ODBC 3X, just as we said we want it, down to the bottom right in the status bar. This is going to be our generic physical design model. So let's do a save as here, file, save as, and I'll just call it generic. This is the place where we can do all of our design that's going to be the same between our two ultimate schemas. And then when we generate the implementation models for each schema, then we'll be able to make the Oracle specific changes and the SQL Server specific changes on those implementation models. So let's do that now. Here we are in our generic model. From the Actions menu, Once again, design layers and derive new model. We're going to derive another physical-only model. This time, let's change from ODBC generic to Oracle version 11G/12C. And the type selection, object selection, everything as before. So we can just push the derive button. Looks much like our ODBC generic model, and of course we want it to. This model, though, targets Oracle. Let me do a quick file save as Oracle. And in our Oracle model, I am going to roll up the subtypes, all of them, into the supertype. So we're going to take all the subtype columns, roll them up into the supertype. So we need to select that relationship from the Actions menu, Transformations. We want a two-table roll-up, and you'll see employee ID. Well, that's already a foreign key here, so we're not going to duplicate that. But you'll see hourly rate, minimum hours, and maximum hours appear in the generic table. Two-table roll-up launches the roll-up wizard. It asks us how many times we want to replicate those columns. It's just one. We're also going to roll up full-time and seasonal. Now, if we were to do this on a combined logical physical Irwin data model, then we would have lost the information from our generalization hierarchy. And it can contain all kinds of interesting stuff. For example, let's just go take a look at our logical model. We might have relationships between the seasonal employee subtype and other entities. Relationships which do not exist between full-time and other entities or between part-time and other entities. There might be some overlap. We might have seasonal part-time employees, seasonal full-time employees. So there's a lot of opportunities, and we can model those logically because we're not constrained to having everything in a relational sense. It's very, very powerful logical modeling. But if we did this, if we did those two-table roll-ups, the three of them that we just did a few minutes ago, in a combined Irwin DM model, logical and physical, all of that information would be lost. And all of those other entities that our subtypes had been connected to, they'd be connected to the employee entity. We wouldn't have any idea how to write the constraints to make those things actually work. Not good. Okay, this is our Oracle model. Let's go back now to the generic physical model, and we're going to derive another model from this. Actions, design layers, derive new model. Target model is physical. Database is going to be SQL Server 2008, I think I said. And we're familiar with the other options here. We won't skip down through all of them again. Just push the derive button. This time I'm just going to roll up the full-time employee. Actions, transformations, two-table roll-up, and step through the same wizard as before. So now our SQL Server implementation model doesn't look like either our logical model or our generic physical design model or our Oracle implementation model. It's unique on its own, but we have all this information in the model maintained so that when it comes time to actually implement from these implementation models, these are the models we'll use to generate DDL scripts, for example. When it comes time to do that, we're all set, and we have links to everything else that show us what are the requirements for all of the constraints that need to be working. Finally, let's save this, just good practice. Save as, and we'll make it SQL Server. So, kind of fun, another physical-only model. We now have a design layer architecture for our models. This is a plan for building things that consists of a single logical specification model describing the business and its information requirements. We have a single generic ODBC, in other words, physical design model where our general, generic kind of physical design decisions are going to be shown. And then we have implementation-specific models for each of the two schemas that we're going to be generating. Design layer architecture, exceedingly powerful stuff. Irwin Data Modeler's design layers approach to data modeling supports complex projects and coordinated workflow. We have dealt with naming things before, several times, in other Irwin DM tool training courses. By the end of this module, you will see Irwin Data Modeler automatically rename all the tables and columns in your data model according to your standards. You'll also know how to double-check its work. In this first demo, we'll see how to create a naming standard glossary from a chosen Irwin DM model. Then we'll put that to use, automatically abbreviating table and column names. In Module 1 of this course, we use the bulk editor, and that's a good place to start building a glossary. It makes it so easy to take information from the model, save it out to a CSV file, and then edit it with some spreadsheet tool, for example, Microsoft Excel. We will show you what the steps are like. From the View menu, Windows, let's fire up the bulk editor pane. Now we want table names and column names. Actually, we want entity names and attribute names, but we have to go with what's given us or what's offered us by the bulk editor wizard. Object types. There are no entities, so let's just select column. No attributes either. So column and table will have to do. Under property types, we have name and physical name. Let's just try name. Object instances will let us see what actually we have. I'm going to take all the tables and all of the columns. The edit button will run our little wizard here and populate the bulk editor. We need to select all the contents that we want to export to a CSV file, and that's everything. Control A will do it, or edit, select all. And then the little diskette button. Save selected rows to CSV file. Have a file name in use out there. Now let's go take a look at that in Excel. Here we are in Excel. So these tabs at the bottom, I'll just step you through very quickly the process that we need to do using Excel as our spreadsheet. Get rid of everything except the names. Change the case in a couple of steps here. Get everything into lowercase. We have a number of table and column names that have multiple words. So we must parse the names into individual words. Excel provides, on the Data tab, text to columns. And the explanation tells you there what we're going to be doing is parsing into individual words. The next tab, deduped, remove all the duplicates. Excel also provides, on the same Data tab, remove duplicates. And then just sorting into alphabetical order leaves us with 58 words. Finally, we want to put those into our glossary format. And we've seen the naming standards glossary before. It has several columns. The first column is the word or words that we're going to ask it to abbreviate. Then we have a column for abbreviations. And column C here would be alternate abbreviations. So we have two sets of abbreviations. Then there are a set of 4 columns describing how we want the word to be used for word order and position. Prime word, those are marked in the first of these 4 columns. Modifier 1, modifier 2, and class word. Finally, we have a wider column here for definitions. Now back to Irwin Data Modeler. From the Tools menu under Standards, Naming Standards, we need to create a new standard up at the top. Use the New button, and I'll rename this Publications. Our goal here is to match whole words only. We don't have to match the whole name. And we want this naming standard to be active, so we'll check the Is Active box. And now, in the bottom section, on the Glossary tab, if we were to push the New button here, we would be able to enter a new word. But that's not what we want, of course. We want to import our glossary. So we will import from CSV, the 4th button from the left. We call that file Publishing Names.csv and open it up. And you can see what we've got. There's our definition for the word address. We have a spare entry at the top. Delete that. This is what we looked at in Excel, and that's what we've imported here. Okay, we've got our standard, matching whole words only. It is an active standard. We have our glossary. Let me close this. This is our logical diagram, unchanged, and let's look at the physical. There we go. Isn't that wonderful? It's an amazing thing. All the tables are named according to our glossary. All the columns named according to our glossary. The views are not automatically renamed because we don't have a match actually for the V. We'll see that in the next demo. Once you set up automatic name abbreviations in your Irwin data model, you'll want to double-check the implementation. After all, as your modeling continues, the logical side of your data model might develop names or words that are not included in the glossary. You'll want to be able to check for those, and you want to be able to update your glossary, of course. Well, now we're going to check to see that our names match our naming standard. From the Tools menu, Standards, check Naming Standards Compliance. It's kind of a spell checker. only it's checking against a very special dictionary. We're going to ask standards compliance to check table names and column names, but not domain names. Notice we could also check word order and position. We'll do that later when we come back and take a second look at this. Start. And it tells us that the view named V author privacy has word or words that are not defined in the currently active naming standard. Glossary. Well, yes, but it's not a table. It's not a column. It's a view. And the same challenge with our view V publisher book. That's it. Everything else matches. So let's finish. So the correct abbreviations are in use. Let's now focus on word order and position. Logical and physical tabs allow us to mark word order and position. So for each kind of word, we have to define what kind of a word it is. The first part in an entity name, we're using prime words, things like order and book and author. Part 2, notice our 4 choices. Prime word, 2 different lists of modifiers. I guess I'll choose a modifier 1 here, and a class word. I'm going to make part 3 our class word. Class words are words that define basically what kind of data we expect to find here. Is it a number? Is it a code? Is it text? And so forth. Attribute names. Again, I'm going to ask for a prime word. And then for part 2, modifier 1. Part 3, a class word. Really, our entities don't have class words. I'm going to remove that. And I'm going to allow a modifier 2 in the case of 3-word names. Now remember what we're calling a word. In a glossary, that's the left-hand column. This could be multiple words. And we need the same definition here on our logical and physical tabs. I'll ignore logical domain names right now. Physical, let's just do similarly here. For table names, prime, modifier 1, modifier 2. Column names, prime, modifier 1, class word. And that'll do it. Now close. And run the standards compliance check for this part of our work. Check word order and position for tables and columns. Table auth does not have all the parts specified in the naming standards file, and these are not going to match up very well because we have not kept track of our naming standards as we've developed the model. But of course in future models we will, because we've got a glossary now, we've got a naming standard. Actually, I bet. Let's just try this. Let's try tools, standards, check naming standards compliance, just for table names. Yeah, they comply. So you see how it works, and you see that we need this naming standard early on in the model development process, or we'll have a whole lot of changing to do later on. In a later module, we'll see how to deploy one naming standard through many different data models with Irwin Data Modeler. It's another wonderful thing. Naming standards evolve. Data models evolve, but they do not evolve at the same pace. We need robust control over how and when changes that we make to our naming standards are allowed to affect the models in which they're used. We call that name hardening. Do you remember when we talked about inheriting versus overriding of names, especially for columns and tables? We work mostly with columns. Okay, well, we'll review that quickly here in a minute, but there's another option we're going to need if we want to develop our naming models using naming standards. Let's take a look first at the column editor. And in the bottom panel, the general panel actually, at the bottom on the right, we see physical name right now is being inherited. The physical name is based on the attribute name. Remember the little drop down with the buttons? Our choices that we talked about were inherit versus override. But there's a third choice we ignored until now, harden. Let's close the column editor. I'll show you another place that we see these choices. And we'll have a little fun here. In the table editor, again on the General tab, physical name. We have those same 3 choices, inherit, override, or harden. Right now our physical name is being inherited. And the inheritance rule is, name it whatever the entity name is. Well, except we've thrown in our little glossary and our naming standards. What about those other choices? For example, override. Well, we don't need to select the override choice here. We can just override manually. Let's rename the cust table client. Now, back to the table properties. Physical name for client is now shown as client, not that macro command. And our little inheritance button shows override. It's got the box with a pencil, override. So we didn't have to select it here first. We just had to type it in, and it fed forward down into this button selection here. Let me go back to the inherit option and see what happens to the name of the table currently named client. We're back to our inheritance rule, and you can see on the diagram above, the name is once again cust. Okay, now for our third choice, harden. The name is hardened as cust. Let's go out and rename it as we did before, client, and click. Whoa! And notice in the advisories pane down at the bottom left. So now that we've introduced naming standards, we want to be able to maintain and update our naming standards. They might be company-wide, enterprise-wide, but we don't want to continually be regenerating new schema. That's for certain. So we might need to change the standard, the naming standard, and then periodically, when we're ready for some other reason, we're ready to change the names and create the new schema. Name hardening lets us override the inheritance of the names and block name changes or resets, whether they're manual or whether they're by some other means, such as our glossary. Again, we don't want to re-engineer every schema for every minor change in the glossary. We decide to implement those changes whenever we want to make the changes, but we still want to keep our naming standard up to date, so we can use hardening to accomplish this. If we had to go through the entire model, table by table and column by column, would be kind of a mess, wouldn't it? So luckily we don't have to do that. Let me cancel out of my table editor and go to the Actions tab. Manage Name Hardening. We have a name hardening wizard. Once again, the overview panel tells you what's going on with this wizard. Type selection and object selection are as you've seen in similar wizards before. Let's say I want to harden all of the table names and all of the column names. Object selection is next. Again, we can choose or select by category. We can limit our changes to subject areas here, one or more. On the right, once again, we see a pane that shows all of our specific instances, checked or unchecked as we need them to be. So nothing new here. All the magic on the name hardening wizard happens in the action link. Entities and attributes, and each of these is expandable again. Notice up at the top the text, please select the actions to take on the objects selected. Items checked will be hardened, and items unchecked will be unhardened. Well, let's just make this very simple here. I am going to harden cust. Oh, it's already hardened. Yeah, that's the way it was. And purchase order. Just the table names, although here they're called entities. Push the apply button and close. Cust and purchase order. Now let's take a look at the table properties. Purchase order is hardened. And cust is also hardened. So if I try to make a change to purchase order here and call it, let's say, buy stuff. Not allowed. This name is hardened. So the wizard allows us to make these hardening choices in big chunks, big blocks of entity table names and of attribute column names. So if we'd like to remove these, we can do it individually, or we can, once again, select columns and tables. Object selection, we'll leave those alone. And on the Action tab, look under our entities. I'm going to clear the checkbox for cust and clear the checkbox for purchase order. Push the apply button and then close. Now we should be able to rename customer as client if we wanted to, and purchase order as buy stuff. But who wants to do that? Back to the Actions tab, Manage Name Hardening. Rather than going into the table editor and working on the individuals here, I'd just like to show you one more time the wizard. Type selection, column and table. Object selection, everything checked. Action. So the wizard lets us go from hardened to unhardened, but it doesn't let us control inheritance versus overridden. For that, we'll have to return to the column properties editor, or the table properties editor, or whatever editor we're working on. I'm going to restore customer back to inheritance, and also buy stuff back to inheritance. And we've got back cust and purchase order. So using the tool under Actions, Manage Name Hardening, we can make these changes from hardened to unhardened, many at one time, instead of jumping around in the table editor, the column editor, and so on. We don't want to re-engineer every schema for every minor change of the schema or for every minor change in the naming standards. Name hardening provides detailed control easily over how and when the naming standard changes are permitted to affect the data models. Themes, subject areas, diagrams, domains, naming standards. We have done a lot of work to build great power into our IRWIN-DM data model. Must we rebuild this stuff for every new model or every new project? As you continue with IRWIN-DM tool training, you will continue to learn about additional reusable modeling power. You'll see many more ways to build this power into your templates. In this and other IRWIN-DM courses, I've made several points over and over again. One of my favorite is this: if we can make modeling standards serve the needs of the modeler, as well as the needs of the project, the needs of the client, the needs of the enterprise, then the standards will be applied eagerly. Well, here we are in Module 7. We've got some really big ideas here, and they're really easy to do. First of all, let's review some of the most productive changes that we've made to our models. It's hard to get more productive than user-defined domains. Now, if you look in this model, up in the Model Explorer, we have a few user-defined domains. Let me build a couple of entities here. And we'll call the first one widget. And the second we'll call stuff. Now let's put some of our user-defined domains to work. Remember what made them wonderful. Phone area code, drag and drop below the line in widget, and it becomes a non-key attribute named widget phone area code. Phone number, widget phone number. And let's do the same two things in stuff. Well, that's wonderful. And you can see if we keep developing our user-defined domains, we would eventually have, I don't know, I'll bet I could rattle off 30 or 35 useful domains right now. It would be nice, the next model we started, if we could have all those domains already built. Something else would be nice to have when we begin. From the model menu, model properties, take a look at our referential integrity defaults. Now I've set these up to do a few restricts. So child delete restrict in every case, no matter what kind of relationship. Well, there's a lot of changes here. I wish I didn't have to do all those every time I started a new model. Diagrams. We only have 2 diagrams in this subject area. But this is the model subject area. I'd like to begin each new model with a model subject area, and with a logical diagram, and with a physical diagram. What else do we have? Themes. Something else I'd like to have a complete set of when I begin a new model. Something we've done more recently. Naming standards. I'd like to have all this stuff predefined for me when I begin a new model. It would allow me, of course, to develop the standards as we develop models. You know, the group of modelers comes up with new ideas for improving a standard or implementing another standard. And we have many ways in IRWIN Data Modeler for implementing standards that benefit the modeler right at the time when they're modeling. But you can see it would take certainly the better part of a day, if not longer, just to get this background information, these background standards established before we begin actually modeling with that new model. We're going to create something called a model template. And we're going to do a couple of dramatic things here. By the way, notice we do have some themes in the Model Explorer. Subject areas, book, I wouldn't need that. Order, maybe test. What about entities? No, I don't need any entities. I think I'll just do this on a diagram. I'm going to delete all the entities. Control A or Edit, select all, and delete from model. Let's see on the physical side. Well, we're left with a view. Is that our only view? Let me scroll down. No, we have a couple of views. Let's delete both of those. Validation rules. Oh, area code validation rules, state code. I'd like to keep those. I'd like to have those in a starting point model. You see where this is going? We're going to wind up with a very nice starting point model. It's going to have our model subject area in it. That subject area is going to begin with a logical diagram and a physical diagram. We're going to have the themes that we've built. We're going to have the naming standard that we built. All of our user-defined domains. The only thing this new model isn't going to have is entities and tables. We should check the physical side. There might be physical-only tables. No physical-only tables. Okay, I tend to look at the logical side as the beginning of things. So I'll go back to the logical side. Now I'm going to save this. File, Save As, or there's Model Template. We'll show the very simple way first. I'm going to call this My SQL Server Template. And Save As type, Irwin DM Template. Very good. And close it. Time now to begin a new model. What kind of a model do I want? I want a logical physical model, and it's going to be SQL Server model. Let's see if any templates out here. Looks like I'm going to have to go searching, browse files, or browse the Mart. We're not connected to a Mart. There we go. So this is my template, and OK. Let's see what we have. Do we have domains? Here's our phone stuff domains, and things like city, first name, ID. What about those themes that we saved? Yes, indeed. Validation rules? Yes. Did we save any default values? Yes, we did. No entities, no tables. What about our naming standard? Tools, standards, naming standards. There we go. So I can begin right away creating entities. Let's take a look at the physical side. Aha! So I'm guessing that our glossary does not include the word vendor, but it did include the word customer, and phone, and number, and area code. Oh, no vendor, but we could include vendor. We'll just add vendor. Abbreviation, I guess, VNDR, and we'll let it be a prime word. Close. Boom. Takes effect right away. But we're starting a new model with all of that reusable, wonderful stuff that we created in our earlier model. And we just saved, even with this little bit that we've got, we've saved a lot of work. There's an option when we create a new model. As we saw before, we looked up the new template. But this option down at the bottom left, preserve the template binding. If we check that, this is going to allow us to keep our model up to date with changes that might be made to the template. But let's create a brand new model and preserve the template binding. What that does is give us all these choices under the File menu, Model Templates. For template information, refreshing the template, we can unbind it to find filters. It's automatically going to be synchronized on model load. The only challenge when we do this is you have to keep track of where those templates are. So you need some standard, maybe some shared drive. Put them in a Mart. Excellent opportunity. There's another way, a little more orderly, of getting our brand new model and our new template together. Let's just create a new model. Logical physical is okay, just the defaults, whatever's here. Empty, of course. No themes, no validation rules, only the basic Irwin domains. Now from the File menu, select Model Templates. Bind Template. We can find our very own template that we built earlier. I have a choice either to load the entire contents of the template or run the template wizard just to select certain objects. And here we are, validation rules, themes, user-defined domains. And now from the File menu, under Model Templates, we can get template information. All the stuff in that template, binding this model to the template, we have access to all these synchronizations. Notice we have Apply Filter or Edit Filter options as well. What else is up there? Synchronize on model load is automatically checked, but we could disable that. Model Templates save you hours and hours of getting started time. The possibilities of things to include in your set of templates is just tremendous. Organization logos, standard color code legends, standard color palettes in standard styles and standard themes, standard subject areas, each with a set of standard diagrams, themes, and styles, naming standard glossaries, user-defined domains. Remember things also like tools, options, settings. So many reusable items. one of the most effective ways to forward the modeler's efforts is to develop and maintain a set of standard model templates. Irwin Data Modeler has two approaches to basic global searching. Let's look at them now. One technique launches from the menu. The other technique launches from the Model Explorer. Let's start with the menu, the Edit menu. From the Edit menu, there is Find. We also have the hotkey combination of Control F. I like to search for something that I know is not included in the current diagram or, in fact, in the current subject area. Let's look for Publisher. We have case matching capabilities, wildcard, search direction, and so forth. Let's just look for capital P Publisher, Find Next. There we are. And notice the appearance is much like the Model Explorer. We're digging down into metadata as we continue. Whenever it tells us it has a calculated value, Irwin DM means that the value is calculated from some formula, some rule within the entity publisher, publisher itself, attribute publisher name, part of a definition, another attribute. But you see, that's how Edit Find works. We'll take a look at Edit Replace now, but I would like to go look directly at our book subject area so that we can watch what's going on with Edit Replace. Control H will also bring this up. Once again, we're going to find a publisher. This time we want to check the Replace With box and enter Vendor. Find Next. Well, ER model shape, we know that's our entity. We don't have an option to replace that. Find Next. Calculated read only. You just have to step by step. Publisher. Okay, here we are with the entity. And the entity you see on a diagram. I'm going to replace that. Publisher identification, a key group member. Can't replace it directly. I can replace publisher name. Vendor name, there we see it in the diagram. I can replace the word publisher in the definition. Publisher address, let's replace that one. And in the definition again, replace that one. Publisher city, replace. Here we see vendor city. Publisher zip code. Now we get a run at publisher identification as an attribute. Earlier we couldn't change it because it was a member of a foreign key, but we can replace this one with vendor identification. So this Edit, Find, and Replace can be very, very handy. Careful though, it's powerful. Generally it won't let you replace metadata that's too deep into the model. Let's close this. Open up our action log. All these find and replaces I see, I'd like to undo all those right back to the set current subject area before the first find and replace. Undo to selected transaction. Flip over to book. And we've got our publisher back. We've used Irwin Data Modeler's Model Explorer to examine our models in a tree-oriented way. We've not yet worked with the Model Explorer's toolbar. We'll find access to Global Find here. The Model Explorer is an attractive launching point since we can work back and forth between the Find dialog, which as you've just seen is a little busy, and the Model Explorer for a complete understanding where what we're looking at fits into the entire model. Now we're going to examine a Global Find technique that uses the Model Explorer. We'll find the Find button in the toolbar at the top of the Model Explorer, the binoculars. It brings up our familiar Find and Replace dialog. Once again, why not stick with Publisher? And Find Next. As I step through it, looks pretty much like the Edit, Find, and Replace. We can leave the Find and Replace dialog open while we use the Model Explorer, however. It gives us a little bigger, more open view of things with the Model Explorer than we had with this keyhole when we were using the Edit, Find, and Edit Replace. So I personally find it handy to use this Find and Replace in the Model Explorer just because I can open up Model Explorer, examine Model Explorer. It's Put them side by side, see what's going on. If you're in the Model Explorer, the button's handy. So now, in addition to the special capabilities of the bulk editor, we see a more standard kind of a global search and replace approach, launched either from the menu or from the Model Explorer toolbar. In this course, we've studied capabilities of Irwin Data Modeler that go far beyond just building a correct and complete model. We've found ways to work with a model and to work on the model, but our scope has been more toward the model level, not down in the minutia.